As you saw by that backtest, regression-based forecasting can be useful. It's also worth noting that that particular backtest was not spectacular. It did indeed beat the S&P 500, which is important, but it didn't beat it spectacularly. Usually we find that performance in the real world is not as awesome as in backtesting. So we would probably still see good return from that strategy, but it wouldn't be quite the same as we saw in that backtest. So I want to list a few problems we see sometimes with regression-based forecasting. First of all, our forecasts always seem to be noisy and uncertain. So there is value in there, but it has to be accumulated over many trading opportunities. It's hard to know how confident you should be in a forecast. I mentioned in my software demo a moment ago that we could look at standard deviation of the nearest neighbors. That works okay. It's really not too strong of a measure, however. So it's difficult to know how confident you ought to be in any particular forecast. It would be nice if you could know, because that would enable you to essentially bet less on forecasts that are less certain. Additionally, it's not clear how long you should hold a position that might have arisen from a forecast and how you should allocate to that position. These are all challenges using regression-based forecasting. Some of these issues can be addressed using reinforcement learning, where instead of making a forecast of a future price, we have the system learn a policy, and the policy tells the system whether to buy or sell a stock. We'll get to this towards the end of this class, but it's an interesting alternative to the regression-based approaches we're going to use here at the beginning of the class.